Hello everyone and welcome to my channel. In this video I would like to show you how to use mandatory access control in FreeBSD. For that I'm going to show you three things. The first one, how to enforce privileges for processes to bind to ports on the network. The second thing is about the Biba integrity model, how to handle integrity in FreeBSD. And lastly, the Bella Padula model for handling confidentiality. Okay, let's do this. Here I've logged into a machine and the first thing I'm going to try to run a small web server on port 80. And as you might know, normal users do not have the privilege to bind to port 80. Let's see and confirm this. So Python -m http.server on port 80, and as you can see I'm as a regular user on the machine, and this should fail because the port is below 1024. Yes, permission denied. What I would like to do now is to use mandatory access control in FreeBSD to allow a regular user to bind to port 80. But let's see further. If I'm root in the machine and I want to bind to port 80, I can bind to port 80, and this I would like to avoid. I would like to flip the sides here and do not allow root to bind to port 80, but allow a regular user to bind to port 80. For that we need to enable the mandatory access control for ports in FreeBSD. So we need to enable the port ACL, and we do this with kld load mac port ACL. Now it's loaded. Kld stat confirms that this is loaded. And if you would like to have this persistent, I'm just going to quickly show one way of doing that would be to edit bootloader.conf, and here put mac port ACL load equals yes. And when you reboot the system, the mandatory access control for the access control list on the ports would be enabled. Alright, so we just loaded the module. Now let's see if root can still bind to the port. So Python 3m http server on port 80. Yes, root can still do it. And a regular user, by the way, it has an ID 1001. Can we bind to this port? No, we have permission denied. So the first command I'm going to use is to change the privilege port behavior. So I'm going to do an su to root. And now I'm going to go back to the normal user. I'm going to look what is the ID of this user, and it's 1001, and go back to root because we still need to tune a couple of parameters. Let's enable the mandatory access control, sysctl security mandatory access control port ACL rules. And now we are going to say UID of 1001, so this means the user you see on the screen is allowed to bind to TCP port 80. And sysctl security mac port ACL port high is going to be 1023. So this ensures that the mandatory access control goes from all the ports until 1023. And now we need to enable the mandatory access control. Sysctl security mac, okay, port ACL it's enabled, and yeah, we can just try enabled again. Let's see if root can bind to port 80. Root can still bind to port 80, but the interesting thing, can a regular user now bind to port 80? So, and let's try again with Python on getting the server on port 80. And now, as you can see, so Gaziba, the user here with 1001 ID, can now bind to port 80. Can this user bind to port 79? No, it cannot. Can it bind to port 81? No, it cannot. It can bind to port 80 and port 80 only. I'm going to go again to the root user and issue the following command: sysctl security mac port ACL as super user exempt equals 1. Currently is set to 1, and let's put here set to 0. So now let's try and serve with port 80, and this is the thing that I wanted to show before. So I needed to tune this parameter saying root is not exempt from the mandatory access control. So root cannot bind to port 80 now, but let's see again. And the user with ID 1001, can it bind to port 80? Let's see. Yes, it can. So this is a very good way of enforcing separation of processes, and to enforce that systems like web servers and so on are not starting with high privileges. And therefore, if they are hacked, if they are exploited, then the attacker will not gain root access immediately, but will have to work a little bit harder. Okay, so this is the port ACL. Let's disable this. So KLD unload Mac port ACL. And now root should be able to bind again to port 80. And if we go back, the regular user, well, interesting, the regular user can still bind to port 80. So we probably, it was bad. Probably we needed to disable the thing. So let's try to go back and sysctl security Mac port ACL enabled, and probably this is unknown. Okay, so we are going to load KLD load Mac port ACL enabled. Okay, okay, not act ACL. Well, I loaded the module now, so let's make sure that a regular user cannot do anything. So port ACL dot rules equals nothing, and let's just make sure that that this parameter net inet IP port range reserved high equals 1023, which was the original one. And now I'm going to unload KLD unload Mac port ACL. Now let's try to see if root can bind. Root can bind to the port, and a regular user can no longer bind to the port. Now let's focus on integrity of the system and confidentiality. So if you don't know about these modules, the Bell-LaPadula and the Biba model, I have a small explanation here. So let's start with the Bell-LaPadula on the left side, just because we can. This is a model that guarantees confidentiality in a system. So you have some processes or some files which are considered high confidentiality, for example, a secret document, and you have some other files or some processes which are running which have low confidentiality, for example, public documents and so on. To guarantee confidentiality, the most important thing is that the processes that are running with low confidentiality are not able to read the documents with high confidentiality. That is the reason d'etre of secret documents. But interesting enough, this model also says that if you are running a process in high confidentiality, you should not be able to write to a process or to a file with low confidentiality, because that would mean that you are going to exfiltrate documents with high clearance. So this rule is also called the Bell-LaPadula, or the model, or the NRU/NRW. So you're not allowed to read up and you're not allowed to write down. The Biba model is a model that focuses on integrity. So now the idea is you have a high integrity process or file, and you have a low integrity process or file. And because you want to guarantee the integrity, a process with low integrity should not be able to write to a high integrity file or process. This would mean hacking the system. So for example, my system is accessed by someone with public clearance, and they try to change the code for the web server or a file locally in the system that should be protected. And this should be a high integrity file, so it's not allowed to write up. On the other side, if I'm running a process with high integrity, to guarantee this integrity feature, I should not be able to read documents and from processes which are running from a low integrity label. Why? Because my process might be tainted. Here is when you're looking up, so this would be an attacker that is going to actively try to exploit my system by changing the high integrity process to modify it. And here would be an attacker would put something as low integrity, and which I have a process that has high integrity clearance. If it reads the low integrity file, well, it might taint, and it's a way to break the integrity on this high level. So, and this is also called a Biba model, and it's a NWU NRD, meaning not write up, as you can see in this arrow, not read down. Now I'm going to show you how to set this up in FreeBSD, and we are going to start with the Biba model, and then we're going to show the Bell-LaPadula. An important thing that we are going to see here is you cannot load the kernel module like we did with the port ACL, because the system wants to guarantee to have these guarantees on booting, so that there is no possibility to violate this confidentiality or integrity schemes. So we are going to have to load the module into the /boot/loader.conf and reboot the system. Another thing that we're going to need and see, and I think this is especially important for the Bell-LaPadula, maybe the Biba model, we're going to see, maybe I make some mistakes in the video, but this is also how we learn. I think the Bell-LaPadula cannot be used if you're using a ZFS file system, because it requires additional labels in the files. I think the Biba also requires, but I don't know. Probably I need to investigate a little bit further, but well, I'm going to fake things a little bit and create a loopback disk for the Bell-LaPadula model. And let's try first for the Biba without creating this local disk and see if it works. Otherwise, I also created the UFS disk. Okay, so let's do this. So let's start with the Biba model, and here I'm logged into my system, and I'm just going to change to root, and I'm going to edit the bootloader.conf, and I'm going to add here Mac Biba load equals yes. And I'm going to reboot the system. So now we're back into the system, and I was just reviewing my notes, and I actually think that both Biba and Bella Padula require a UFS file system. So yeah, let's just go directly to a UFS file system. If you want to try it with a ZFS file system, please go ahead and be my guest. So let's log in as root. Let's see if the Biba is loaded, KLD KLD stat, not load. And we see here Mac Biba, the mandatory access control for the Biba model is loaded. So let's create a very small disk. Let's say dd dev0 output file equals disk.emg. Count, let's say 16 and block size 1 megabyte. So 16 megabytes, that should be, it should be more than enough. It's a very small disk. Let's see here. So 16 megabytes is really a tiny disk. Now we do an md config -a-t vnode in the file disk image, and we get the device md0. And here we can just create a file system. In another video, which I might have already put out, or maybe it will come later, I show you how to use gpart here, but I don't need any partition. It's just going to occupy a little bit of space and take a little bit of, it's 16 megabytes is too small. Let's just create a disk directly. So new fs, and here is the important thing, -u and -l. The -l is the option that allows multi-label, and dev md0. And that's it. It's formatted the disk. We can try to mount. We need the option multi-label, dev md0, and let's put this under /mnt. Now let's see. So mount. Yeah, that doesn't look so good, or actually it's fine. And we see here that /dev md0 has the multi-label option. So we are getting ready to use the Biba model. Now let's go to /mnt. We can see here, well, there's a directory here with .snap. We don't need a .snap. And let's create two files, show secret high file. And let's save this to secret, or actually it's high.txt. And let's create a public file, low file, and let's put this to low.txt. So currently these files are not, don't have any label. So we are going to put a label. So set file mac, the mandatory access control, biba high. We're going to put the biba high on the high file, and set fmac biba low on the low file. Now let's try to get the labels. Get fmac for high, it's biba high, and for the low, it's biba low. So what is the label that I'm running? So I'm running as root, and what is the label? So get process mac on the PID for my shell, and I'm currently running as biba high, as you can see here. I can start also another process, so which is set process mac biba low, and let's start a shell, and here we are. And let's try again to get biba for this process, and now I'm at biba low. So this is how you start a process. So it's just you start the process by doing the set pmac, give it a label low, and yeah, it's shell. It's a shell. Yeah. So let's exit. Let's confirm that we are again back at high. And to make it easier, I don't need to log in and to log out. Let's just say set pmac biba high. So and now we can run a cat on the high file. So if we are in a process, cat runs as high, and if we want to read a high, well, we have the clearance for that. It's there. But if we are low, we can actually read. So secret might probably not the best, the most appropriate word here. It's a file with high integrity, so it's actually not necessarily a secret, but yeah, let's just keep it like this. Now, now the interesting thing is writing. Now let's look at the other things. So let's look at high. And can high integrity process read a low file? We saw that before this would mean tainting the file. So root, is it allowed to read a public file? It's permission denied. I cannot do this. So let's just say I start a shell and get pmac on the process here. So I'm currently running with Biba high, and I can want just to cat low, and as root I'm not allowed to read this file. Okay, let's exit and let's go back. And if I'm low, if I have low integrity, can I read a low integrity file? Yes, I can. So this is working as expected. Now let's see, can I, if I'm having a high integrity, can I sh? So let's I think this is okay. So hello. Let me see, can I run a shell like this? Hello, not found. Okay, -c echo. Probably it's better like this. So yes, okay. So what I'm trying to do is I'm running a shell and giving it a command, and the command is echo, this one. So let's just give it, instead of the echo, get pmac on the process $, and it's high. So here I'm going to change to low, so you can see that this is working as expected, and it gives me a low. Okay, so now this means that I can start writing. I can do a cat, or actually not a cat, I can do echo, and this is a high writing to a high.txt to this file. Can I do this? Yes, I can. So cat high, and the content has been modified. If I'm high, can I write to a low file? Yes, I can. High integrity processes can write to low files. So cat low, and I cannot read. Why? Because I'm a high integrity. This is the tainting thing. Yeah. So how would I read this? I set myself, for example, as low, and let's verify that this is done. Low, and well, let's cat low text. So as you can see, the content of the file has changed. Okay, so I'm just missing one thing. So I tried Biba high, writing to high. I tried to, with Biba high, I tried to write to a low, and both worked. And now let's do the same thing. Okay, let's do the same thing, but high from low integrity. And this is what should not work. So if I'm running a low integrity process, I should not be able to write to a high integrity file. Let's see. No, it's permission denied. But can I write to a low integrity file? So low.txt, and low from a low integrity. Now let's try. Yes, we can do it. Can I read? Again, I cannot, but I can do the Biba low with cat low, and we see the content has been changed. Alright, so this shows how to use the Biba model in FreeBSD. Now let's try the Bell LaPadula. For that, we need to go again to the bootloader.conf, and it's not a Mac Biba that we want, but the Bell LaPadula is implemented with Mac MLS. I forget what the MLS is, but we can run Mac MLS. So we have, it's the multi-level security. It's a confidentiality policy. Okay. So let's reboot the system. Okay, so there we are again. System has rebooted. Let's go again to the root user and kld stat. And we see here Mac MLS is loaded. So we can do the Bell LaPadula. Now let's mount again this UFS system. So we have an image that is called disk image, the 16 megabytes. So we're going to reuse that. We need to set up the loopback md-config -a t vinode on the disk. So we get md0 and mount -o multi-label on /dev md0 on mnt and mount grep md0, and we have it mounted here with multi-label option, a UFS file system, and we go to here. We still have the files, the high and the low, so let's just remove everything. Okay. And the programs, the things are now very similar. It's just that the policy is called us slightly different. So let's get process Mac on $. So now you can see I'm running with MLS low. So I'm a low confidentiality process. Let's see if actually Mac is enabled, sysctl. I find it a little bit strange that this is low, so it should be high. So let's see security.mac MLS enabled. It's currently set to 1. Okay, so let's see set pmac MLS high sh and get pmac $. It's high. So we are able to switch because we are root. Okay, so interesting. So this is most likely a security feature saying that even if you are root, initially you start with low confidentiality, and you are allowed to elevate your confidentiality, as I've just done here, to high. I'm guessing we can test this afterwards, that a regular user should not be able to go from a low to a high confidentiality grade. So let's exit. Let's reconfirm that we are at the normal low. So this is just as I logged into the system. And here, because we're dealing about confidentiality, before I wrote secret, it was not a secret. In this case, it's confidentiality. It is definitely a top secret. Yeah? So we can create a top secret document and let's call it secret.txt and public document to public.txt. Okay. Now we set file Mac MLS/high on the secret, and let's set the low option. So let's go back and set low on the public. So I currently have the low privilege. Can I read the secret document? Let's see, cat secret permission denied. So this is the interesting thing, because I'm a root. As root, I can change my privilege, but as a normal user, you should not be able to do this, right? So yeah, as root, I'm not able to read the document I just created. Can I read the public document? Yes, I can. If I change to a high role, so let's start again a new shell. So set process Mac, switch to high, start a new shell. Let's just confirm that I'm at high. So MLS high. Can I cat secret? Yes, now I can. Can I cat public? Yes, I can. Now as a high confidentiality, with a high confidentiality clearance, I'm able to read the top secret document. And what about changing? So let's go back first to the, so log out, Control D. Let's just show you that I'm back to the low. Can a low process change a confidential document? So echo hello from low, and let's write to the secret. I can, and echo hello from low again, and go to the public, and I can also change this. But you remember the Bella Padula is no write down, because we don't want data to be exfiltrated. So let's elevate us to high and see if we can write down. So we set ourselves at high, and now we try to do the same thing. So echo hello from high. Can I write to the secret? Yes, I can, because I'm at the high level clearance and I can change the secret document. Echo hello from high again. And can I write into a public document with public clearance? No, I cannot. I cannot exfiltrate data. These together with file permissions and eventually access control lists makes for a very robust enforcement of policies in your FreeBSD system. Alright, so that's it for today. If you enjoyed the content, please give it a thumbs up, and if you have some comments or suggestions, please use the space down below. From my side, thank you for passing by, take care, see you next time, bye bye!